right, so this is chapter 12, section 2. Chapter 12 is circles, and section 2 is chords and arcs. Your learning objective is that you will use congruent chords, arcs, and central angles, and you'll use perpendicular bisectors to chords. So the only vocabulary word you have in this section is the word chord, which is a segment whose endpoints are on a circle. So if you look here, I have circle O, and P and Q are endpoints, and they're on the circle, and the chord goes right across the circle. Okay, so section 12-2 has a bunch of important formulas, so definitely want to note each of these formulas. So theorem 12-4 and its converse are congruent central angles have congruent arcs. Example, if AOB is congruent to COD, then arc AB is congruent to arc CD. And remember, central angles go through this, their vertex is on the center of the angle. So the converse of this is true as well. If arc AB is congruent to arc CD, then angle AOB is congruent to angle COD. Definitely having the picture is helpful for these parts. All right, theorem 12-3. Or 12-5. There it is. So theorem 12-5 and its converse, if angle AOB is congruent to COD, just like before, then length AB is congruent to length CD. And the converse of that is true. If my two line segments are congruent, then I know my angles are congruent. All right, theorem 12-6 and its converse. Check this one out. If AB is congruent to CD, then arc AB is congruent to arc CD. And the converse of that is true. If the arcs are congruent, then this side line segments are congruent. All right, theorem 12-7. Collecting them out. So here's O right in the center. Theorem 12-7 says if OE, E is up here, this is OE, is congruent to OF, then AB is congruent to CD. So AB is here. It's congruent to CD. And OE is congruent. And the converse is true. If AB is congruent to CD, then OE is congruent to OF. It's 10. I believe, let's see if 8 is over here. Theorem 12-8. Right here. So if we have a circle with center O and a diameter AB that goes through the center, and a chord CD, then if AB is a diameter and AB is perpendicular to CD, then CE is congruent to ED. And arc CA is congruent to arc AD. Okay, 12:9. If I have a same scenario, if AB is a diameter and CE is congruent to ED, then AB is congruent to CD. So if I have the scenario where AB is the diameter again, and I can prove that these two line segments are congruent, then we can say that AB is perpendicular to CD. All right, our last formula for this segment is theorem 12-10. If AB is perpendicular to CD, is a perpendicular bisector. So not only is it perpendicular, but it also cuts it in half. Then AB contains the center O. So if you know that AB is a perpendicular bisector to a chord, you can then conclude that AB is a diameter, and it goes through the center of the circle.